Hello friends, in continuation of the instructional videos on the LS 100 inverter, today we want to teach you how to set the frequency using the pulse input on the 100 inverter. In order for the frequency reference of the 100 inverter to be set from the pulse input, that is, if we want to provide frequency to our inverter through the pulse input and have our frequency reference on the pulse input, we need to set the FRQ parameter in the main operation group to the value 12. In these videos, our start command is given through the inverter's own keypad, so the DRV parameter in the main operation group should be set to 0, which means keypad. But what other settings do we need to configure on the inverter for this purpose? To activate our pulse input and have the inverter take its frequency reference from the pulse inputs so that our frequency is set via the pulse inputs, if we want to assign one of the inverter's control inputs as a pulse input, we need to configure one of the digital inputs from P1 to P5, which correspond to parameters in 65 to in 69. In 65 is for P1 and in 69 is for P5, to the value 54. In the multiple models of the S100 inverter, there is a dedicated pulse input, meaning the TI input terminal is specifically for pulse input. However, in the standard models, which do not have a separate pulse input, we need to define one of the digital inputs from P1 to P5 as a pulse input. For this example, we want to set digital input P5 as the pulse input, so we should set parameter in 69 to 54. If we set it to 54, digital input P5 will be recognized as a pulse input. For pulse inputs, when the frequency reference is set to pulse, just like with analog inputs, we need to specify 2 points for the inverter, the minimum and maximum points. In the S100 inverter, we can have a pulse width from 0 to 32 kHz. We need to specify what frequency the inverter should output at 0 kHz, using IN93 and IN94, and at the maximum value, which is 32 kHz, what the inverter frequency should be. So, just like with analog inputs, we need to define these 2 points for the inverter. The maximum pulse width we can have in these standard inverters is 32 kHz, which can be set in parameter in 95, and the corresponding frequency for this pulse width can be set in parameter in 96. In this tutorial video, we are going to synchronize 2 inverters together. What does that mean? For example, let's say we want to set the frequency to 30 Hz on the IP5A inverter. We also need to have the same 30 Hz on the S100 inverter. In other words, both inverters should receive the same frequency value at the same time. So what should we do? Here we have an IP5A inverter. We've connected its output to this motor, and now we want to set it to 30 Hz. On this motor, you can see an encoder that's mounted on the shaft of the electric motor. We want to connect this encoder to the inverter, and by using the pulses sent from the encoder, provide the frequency value to the inverter. We want to set the frequency reference of the 100 inverter to pulse. So whatever value the IP5A inverter has, the 100 inverter should also have the same value using the pulses that this encoder sends to the 100 inverter. But how should we do the wiring? Since we only want to use one pulse from our encoder, or specifically its A phase, we will use 3 wires from this encoder. As we've written here, we connect the blue wire of this encoder to the CM terminal, which is our common terminal. Our black wire is the one related to the phase A pulse, and we connect it to terminal P5, which is defined as the pulse input. The brown wire, which is the encoder's power supply, is connected to the 24-volt terminal of the inverter. So, our encoder has 3 wires for phase A. We connect its ground, the blue wire, to the CM terminal, the phase A pulse, the black wire, to terminal P5, which is defined as the pulse input, and the encoder's power supply, the brown wire, to the inverter's 24-volt terminal. The encoder we're using here is mounted on the shaft of an electrometer, and it's an Autonix brand encoder with the code E50S8-1024-6-L-24. So to summarize, we want to set our frequency reference via the pulse input. We need to set the free Q parameter in the main group to 12. Our direction control is via the start button, and our stop is set through the inverter's own keypad. Now, let's go and apply all the settings we've discussed so far and everything we've learned to the equipment and test this feature together.
So as we said, if you want the frequency reference to be set by the pulse input, that is for our frequency to be controlled by the pulse input, you need to set the FRQ parameter in the main group to 12. Let's go to the FRQ parameter, set it to 12 and confirm it. The start command is also given through the inverter's own keypad, so we should set the DRV parameter to 0. Now we want to configure the pulse input. We need to set the pulse terminal on parameter in 69, which is related to the digital input P5. So let's go to parameter in 69. IN69 is related to the digital input P5. We want P5 to act as the pulse input, so we set it to value 54. If we set it to 54, our P5 terminal will function as the pulse input. Okay, we've completed the settings on the S100 inverter. I'm going to run the inverter now. My frequency is 0. Here we have an IP5A inverter. As you can see, we've set the same value on the IP5A inverter. If I start the IP5A inverter, my motor will begin to rotate, and with this action my encoder will send pulses to the S100 inverter. When my IP5A inverter displays a frequency of 30 Hz, my S100 inverter should also display the same frequency. Now, I'm going to start the IP5A inverter. As you can see, my motor starts to rotate and my encoder sends pulses to the S100 inverter. You can see that my S100 inverter, with only a few thousandths of a percent error, now shows a frequency value of 30 Hz. Now, I'm going to change the frequency value on the IP5A inverter. For example, I'll set it to 50 Hz. You can see that as the frequency value increases on the IP5A inverter, the frequency value on the S100 inverter also increases and shows us 50 Hz. With this we were able to synchronize the two inverters, meaning whatever frequency the IP5A inverter has, my S100 inverter will have the same value. How did we do this? With a single encoder, the IP5A inverter was set to start the electromotor, and with the encoder that was coupled to the shaft of the electromotor, the pulses were sent to the S100 inverter. The S100 inverter was also set to use the pulse input as its frequency reference, and through these pulses that we sent to the inverter, its frequency was determined.